Welcome to our project on predicting house prices using machine learning. In this video, we'll take you through the steps of developing a machine learning model to predict house prices using regression analysis. This project will demonstrate how data can drive real-world predictions with accuracy, offering value to industries like real estate, banking, and investment. The goal of this project is to build a regression model that can predict the price of houses based on various factors such as location, number of rooms, square footage, and more. Accurate predictions can help buyers, sellers, and real estate agents make informed decisions. We'll be using a dataset that includes multiple features of houses like location, number of bedrooms, size in square feet, year built, and of course, the price. These features will act as inputs for our machine learning model. The next step is data preprocessing, which involves cleaning the data, handling missing values, and selecting the relevant features. In this project, we'll also normalize the data to ensure that our model performs efficiently and accurately. Once the data is clean, we perform exploratory data analysis. This step helps us visualize relationships between the features and house prices. For instance, we might observe that houses in certain neighborhoods tend to have higher prices, or that larger homes generally cost more. For this project, we'll test multiple models, including linear regression, decision trees, and random forests. We'll evaluate each model based on performance metrics such as mean squared error, MSE, and R-squared score. After selecting the models, we split the data into training and testing sets. Using the training set, we train our models to learn the patterns and relationships between features and house prices. Once the models are trained, we evaluate their performance using the test set. We compare the predicted house prices to the actual prices to measure the accuracy of each model. Based on the evaluations, we choose the best performing model. In our case, the random forest regression produced the most accurate results. The model can now predict house prices with a high degree of accuracy. In conclusion, we successfully built a machine learning model to predict house prices using regression. This project demonstrates how machine learning can offer practical insights into real-world problems, providing valuable predictions that can aid in decision-making. In this part of the project, we evaluate 3 models: linear regression, decision tree, and random forest. The code demonstrates how we trained and tested each model on the dataset and used mean squared error, MSE, to compare their performance. The results show that random forest outperforms the other models in terms of accuracy. Code explanation: data splitting. We split the dataset into training and testing sets using train_test_split. This ensures that the model is evaluated on unseen data, preventing overfitting. Linear regression model. We create and train a linear regression model using linear regression. It's a simple and interpretable model that assumes a linear relationship between the features and the target variable, house prices. Decision tree model. A decision tree regressor is trained using decision tree regressor. It splits the data into branches to make predictions, which can capture more complex relationships in the data. Random forest model. The random forest regressor is trained using random forest regressor. It is an ensemble of multiple decision trees, which improves accuracy by averaging the predictions from many models, reducing variance. Mean squared error, MSE. We use mean squared error, MSE, to evaluate each model. MSE measures the average of the squares of the errors between predicted and actual values. Lower MSE values indicate better model performance. Results: the model with the lowest MSE, likely the random forest, is selected as the best model for predicting house prices. For future improvements, we could include additional features like economic indicators or neighborhood crime rates to enhance the model's accuracy. We could also integrate this model into a web application for real-time house price predictions.